In the context of the European CityChlor project, the Public Waste Agency of Flanders is testing an innovative remediation technique to tackle groundwater pollution in an urban environment. The pilot test is carried out on the site of a former printing office in the community of Herk de Stad, located in Belgium. For years, leftovers of solvents were dumped in a drain on the site. Nowadays there are some trees and concrete with a garage on this location. The former activities caused a pollution in ground and groundwater with chlorinated solvents that has spread under the building and the connecting parcels. The pollution with chlorinated solvents is located between 2 and 7 meters below the surface and consists mostly of perchloroethylene and in a limited extent of trichloroethylene. There is almost no natural degradation of the pollution at the site. The MIP, or Membrane Interface Probe, is a screening tool that is already widely used in soil investigation. It allows for fast, on-site, real-time detection of pollution with volatile or semi-volatile contaminants. It does not allow us to differentiate between individual contaminants. At the pilot site in Herk de Stad, this is not a problem, because we know the type of pollution we're looking for. Because we wanted to confirm the presence or the absence of DNAPL on the pilot site, some extra MIPs were executed. Based on the observation during the fieldwork and the analytical results, no DNAPL could be detected in the injection zone. During the further characterization of the pollution, 3 drillings were placed in the zone that most likely contained the source of the contamination, based upon the results of previous soil investigation. The drillings were realized by means of sonic drilling. Sonic drilling is a drill technique that uses high-frequent vibrations between 50 to 120 Hz to drive the drill bit into the ground. The vibrations fluidize the soil particulates in the vicinity of the drill bit. The soil particulates are literally pushed aside by the drill bit. In all of the drillings, the soil was screened from groundwater level, approximately 3 meters below ground level, to 3 different depths: 5 meters below groundwater level, 10 meters below groundwater level, and 15 meters below groundwater level. The soil samples were taken by means of aqualock sampling. The aqualock sampler is a steel casing with a length between 2 and 4 meters, with a strong piston on the inside. The position of the piston can be regulated by hydraulic pressure on top of the piston. The aqualock sampler is used to precisely sample the soil, undisturbed soil samples, with minimum loss of soil structure. While drilling to the desired depth, the piston resides in the tip of the drill. When the desired depth is reached, the hydraulic pressure decreases. In ideal circumstances, the piston stays at the same position, while the steel casing moves further down, taking the soil sample. Above ground, the soil sample can be extruded with the piston. Soil samples can be extruded in plastic liners. Afterwards, monitoring wells were installed in all 3 drillings. Based upon the analytical results and the observations during the fieldwork, no dense non-aqueous phase liquid could be detected in the injection zone. Based on the analytical results, the contamination is mainly present in the top layer, between 0 and 5 meters below groundwater level, between 0 and 5 meters below groundwater level. Only tetrachloroethylene was detected in the soil, and elevated concentrations, with a maximum concentration of 20,000 micrograms per litre, were detected in the groundwater, between 3 and 15 meters below groundwater level. Based on the results of the soil survey, the injections with 0 valent iron should take place in the soil layer between 3 and 5 meters below groundwater level. 0 valent iron can facilitate the process of anaerobic dechlorination. Therefore, the injection of nano and micro 0 valent iron particles for the remediation of the source zone of chlorinated solvent pollution is tested at the pilot site. The difficulty in the tackling of source zones of pollution by using this facilitator is bringing the iron in contact with the pollution. Small-scale iron particles could be a solution because they move through the subsoil with the groundwater flow and can penetrate into the smallest pores. The nano iron we used is NanOffer 25S, coming from the Czech Republic. The micro-rin we used in the product FG00000080, coming from Gotthard Meyer Metalpulver in Germany. We mixed the micro-iron with glycerol as a stabilizator, which decreased the deposition velocity. After the mixing of the iron with water, nitrogen gas was added to make the mixture anaerobic. In total, 6 iron injections were executed at the site, each in a triangular form, between 2 and 8 meters below the surface. The technique used for the injection is a top-down direct push injection. The nano-iron was injected 3 times in a mixture with water. 10 to 20 grams of nano-iron was added to 1 liter of water. The micro-iron was also injected 3 times. Every half meter, 25 liters of the product was injected. In each injection point, 325 liters of the mixture was injected. A flow meter was used to estimate the quantity of the product. A few days after the injection, liners were taken on different depths to evaluate the spreading of the injected iron. At the same time, groundwater wells were placed to function as a monitoring well. The full report of the pilot project with the injections of zero-valent iron can be found on the CityChlor website.